can be taken as the representative of the complete data set. That's what measure of central tendency means. Okay, let me write it down. So measure of central, this is a, so out of the multiple data points, a single statistical data point will give me one value that is representative. A single statistical value that describes a typical or central point, a representative, a typical or central point of data set. Okay, so this is a representative, as I mentioned, this is a representative, single representative. And most of these concepts you must have learned in school itself. Okay, this is just a revision and plus more information around how we understand it with respect to data and machine learning. Okay, some more insights based on the fundamentals. So this is what it means. Why did we learn these concepts? Because when we have a data point, and this can be used for comparing central tendencies. Means, say for example, this is for a single data set. For example, I have two sets of people. Okay, so I have people from okay, one class, okay, and people from another class. Say standard, you have like people from one standard 5 class and then standard 8 class, and you measure all the people height and take the average height. So you can compare two group of children height now, right? So standard 5 children will be smaller on an average than standard 8 children. So that's what we can compare to. Are all children taller or smaller in class 5 or than the children in standard 8? No, right? So we take one representative which will be the average, and we can compare two groups using this central tendency. That this is a typical or representative data which represents these two groups, and now I can compare these two groups using this central data point or the typical data point on the representative data point. And that's what this measure of central tendency means. I hope this measure of central tendency is clear now. Why are we studying these things? Always I'll go via this flow only. Why are we studying this? Okay, so the first thing would be mean. We have studied this a lot. When mean means mean or average. We know this. Okay, this is the most common. This is the most common we use. This is most common. Okay. Now what is mean? It is simply but okay. Generally we say this is the balancing point of the data set. Mean would be like just at the center. It's balancing point of the data set. Okay. And for example, if I say there are 5 data points. Okay. Mean of, I'll take very simple example so that just the intuition is clear and then I won't complicate the maths. So this would be sum of all 1 plus 2 plus 3 plus 4 plus 5 by 5, and this will come out to be 3. Okay, so you know this is the average. Sum of all by the count. This is n and this is sum. This we know already. Okay, and if we go further, so there are two kinds of means. One is sample mean. So we have a sample which we take as a representative of the population generally, and one we have population mean. That is for the complete population. For example, we say that average height of Indian people is 5 feet 6 inch. So that's the population mean. This is mu. Okay, represented by mu. But are we going and measuring the height of each and every person in India? That's not the case, right? So what do? We take a sample, and that's what is assumed to be a good representative sample, and this data, whatever it comes out, that's a good representative of the population mean. So this is your population mean, this is your sample mean. Okay, and then we'll further read about central limit theorem, etc., which will justify how this sample mean can be taken for all practical purposes when n is very large. That is the equal to population mean. Okay, but this is for understanding. X bar is sample mean and population mean is mu. Okay, that's the simple. So what are the good things about it? What are the pros? So I'll make comparative analysis. So what are the pros of this? So pros is that we are taking all the data points. So all these data points are taken into consideration because we are summing up all the data points and then we are taking the average. So all the data points are included. Okay, that's the pro. all data points are considered. Okay, and what is the cons for this? That if I have outlier, it is highly sensitive to outlier. Highly sensitive to outliers or extreme values in my data set. Outliers or extreme values. Outliers means extreme values. For example, if I have, for example, my same data set is, if I have to find the mean of 1, 2, 3, 4 and 100. So instead of 5, now I am having 100. So this is an outlier, extreme value. All these were in the same range, but this is an outlier, extreme. But what will be my mean? What will be my mean now? This will be 1 plus 2 plus 3 plus 4 plus 100 by 5. This will become 22. So see, my earlier mean was 3 and just one outlier brought it to 22. So this is very sensitive to outliers, my mean. So that's why we have to handle these mean outliers or some other mechanism we use. Okay, so you can see that in this data there's nothing like 22. Most of the data is 1, 2, 3, 4 only, but just 100 is pulling it to 22, and we are telling that okay, this is the representative of the complete sample, but that's not the case. This is happening because of the outlier we have. Similarly, if the outliers go even high, 1000, you just pull the value towards it, which will not be the representative of the data. So this is a con of this measure. So that's why we have different kinds of measures. Just mean would be sufficient otherwise. So to address this problem, we have something called median. What is median? Median is a central value, right? Middle value in sorted, we sort the values in ascending order, and the middle value, exact middle value is my median. That's a simple thing. So middle value in sorted data set, even that is a good representative. So we sort everything in ascending order and just take the central value. That's the measure my central tendency. So everything is sorted. Okay. So this is more robust to outliers. Okay. More robust. So that's it. It's pro. More robust to outlier than the mean. Okay. And if you take the whole data set, right? Say for example, the same data set, for example, median of 1, 2, 3, 4, 5. So this will be equal to the middle value. So this will be n plus 1 by 2th value. So this is 5 plus 1 by 2, that is 3. So my median will be 3 here. And if you see that median is the just central value, it will divide the complete data set into exact 2 halves. That's the median, central. 1 half and 2 half. That's median. And if it's n is even, then what do we do? For example, median of 1, 2, 3, 4, 5, 6, then this is n plus 1 by 2th. So that is 7 by 2, that is 3.5th element. What is 3.5th element? In the middle of 3 and 4. So the middle would be here, 3.5. 3.5th element is the 3.5th element here. So this will be average of 3 plus 4 here, because my data is also like that, that is 3 plus 4 by 2. So if you can see here, even this divides the data into 2 parts. So the definition holds, and this is the exact middle. Okay. So this is for odd and even. So the pro, what I mentioned, this is a pro, that it is more robust or not impacted by outliers. Okay. This is pro is not impacted by outliers. This is the problem that we are solving when we have outliers, not impacted by outliers. How is it not impacted by outliers or extreme values? Say for example, in the same one, if I have median of 1, 2, 3, 4 and 100. So this will be my n plus 2th value only, right? And this will still be 3. Even if I have 100 here, because everything is sorted in ascending order and I take the middle value. So this doesn't impact. That's how that's why it is robust to outliers. Okay, the median. And the cons is, what is the con? We are looking at the middle element. Okay, does not it does not take into account all the values. It is just taking the middle value. What is just finding one value which is there. It is not taking into account other values. Okay, so that's a con. It is not talking about other values. Okay, as you see here, right, in this, it is taking into consideration all the values. It is summing them up. So the contribution is from all the values in the mean. But in median, no, just one value. What is the central value? I'm just talking about that. I'm not looking at the other values at all. Just the central position. Okay, that's a con. Does not use complete information in dataset. Only one value, complete information in dataset. That's the con of this. I hope median is clear. Then the next is simple mode. What is mode? Mode is the frequency, highest frequency. Okay, most frequent value in dataset. For example, mode of 1, 2, 2, 2 and 3. What will be the mode? It should be equal to 2 because 2 is there 3 times. Okay, this is the mode, most frequent value. This is simple. Okay, and why are we studying this? Because always the numbers may not be, means always when we are dealing with data, they may not be numbers only. Sometimes we are dealing with categories. So whenever we are dealing with categorical data, so useful. Okay, useful here for categorical data. For example, when we are discussing about gender, okay, male, female, others, whatever. So whenever you're talking about that, so this mode of the data will give me that the data that I have collected, okay, it has more male or more female. So whatever is more, right, that will be the mode of my data in this category. Or ethnicity, blood group. So I can count which is the most frequent blood group. For example, what is the most common blood group, right? So in case of blood group, so in a sample I can find out what is the representative. For example, in a sample, 7 out of 10 are female. So I can tell that female is the representative here, right? The 7, that is the most frequent if we have male and female only. Okay, so female will be the mode. So because the mode is 7 and rest 3 are only male, so this will be my mode. So in categorical data this becomes very important because we cannot measure in any other way. How will you count? Okay, so that will give me. Similarly, blood group, so there are different blood groups are there, right? A, B, O, like that, both positive, negative, etc. Okay, so from this samples we can find out what is the, and if I take a sample of people and then I ask you like which is the representative blood group. So in such kind of categorical data, okay, there this is very helpful. Which is the most frequent blood group, that will be the representative or central tendency of that sample. I hope this is clear. What is this? Okay, so this is the pro also. So this is the pro. This is the central tendency used for only, that is used for categorical data which cannot be counted, okay, which does not have numbers. So categorical data, and this is only in the categorical data is of 2 types. This is nominal, what I'm talking about, and there is ordinal, there is some order in that. So I will discuss about that later, but understand broadly this is categorical data. Okay, we have certain group of data and we want to find which category or group is most frequent, and that's how we can measure that each group. Okay, so if we measure the frequency of each mode, each frequency of each category, that will give me the mode or the central tendency of that sample. I hope mode is clear in the utility why we are studying. Okay, mean and median doesn't measure that, so mode is useful for this categorical data.